Hello guys, welcome back to Carry Code. In this video, we are going to see about one more interesting project, that is image classification. In this video, we are going to discuss about the fruit classification under the image classification category. So as usual, let's create a Jupyter notebook first. Let me rename it. And the first step is to import all the libraries. Right guys, let's import all of them. Import numpy as np, import pandas as pd, import matplotlib.pyplot as plt, import cbon as sns, import tensorflow as tf. So after that, I will import some libraries here to save the time now. Let's import all of them by running this cell. So until it runs, let me explain you this. So image classification, under this category I took fruits as a input image to my model, and for that, to train this model, I took the images of all the fruits of different kinds. Like this train folder is having all the training dataset. That means under this train folder we have different folders of fruits. Under that each folder we will be having different images of fruits. I'll be showing you all of them now. And under this test folder we can see all the test data without any labels. You see random images of any fruits. Okay, so the next step is to see our train data, how it looks, right? So to do that, we can take all the paths inside this train folder or directory and see how the file names and images are structured, right? Let's see. So we will use this walk function in this OS library to walk through all the directories and folders, also the files inside the training folder, right? So we have to give the path for this train. So inside this train, if you see, there is one more train folder. Inside this train, we have different types of folders of different fruits, and if we go inside this each folder, there will be so many images of that kind of fruit, right? So what can I do is, the main train images are under this train folders, right? So let's take that folder path as our walkthrough, right? /train like that. So this will be giving the walkthrough to our all the files and folders, walkthrough to the all the files and folders inside this path. Let me make it into list and store it inside a variable like all training files, like that. Let's run it. So let's see how it looks. Print off all training files. So this is a list of all the directories and files inside this input path. So let us observe this list one by one. Let's take first index. If you observe this, the first index, you see it is a tuple of 3 values. The first value is nothing but the path, and the second value is a list of folders, and third must be the list of files, right? Let's observe the first index again. So it is 3. It is nothing but the same structure here. The first one is nothing but the path, that is the apple path here. It is given. It is taking the first folder inside this train, and then next it is taking the list of folders inside this path. So there are no folders, it is empty, and it is taking all the file names inside this folder. So these are the file names. One by one, it is taking as input and storing it in a list, right? So what is the structure of this all training files? It is a list of tuples which are having list of tuples. So it is a list of tuples which is having a length of 3, right? Tuple length of 3, commands on like that. So what is this 3 length tuple consists of? You know, it has the first part as the path to that second files or folders, right? And second one is the list of directories, and third one is nothing but the list of files in that path, right? So first one is the path, this train/train or the train/train and the folder name. This is the path. And second one is the directories, list of directories, the list of folders inside this path, and the list of file names inside this path again, right? So if we move forward, we can observe these are the training file names or the list of categories, different type of fruit classes we are going to train in our model. So let's store these values in our classes variable, right? So let's take, so if I take all training files, and if I take the first index, then then the first index is nothing but, if you see, it is a tuple of 3 length, right? We need the first index, not the 0th index or the last index. We need the first index, right? So we'll take the first index like this, and these are nothing but all the classes, right? Let's see these classes now. If you observe, these are all the classes we took from the folder, training folder, right? Let's take the length of those. Let's see the length of these classes now. So it is 33. So we have 33 kind of different fruits here. We can take all of them for our training, and we'll be having different type of fruits in the test folder also. So we can test with that folder using our model. So we use those test folder to test our model. So if we want to take only the training files here, we have to take from the first index, right? Not from 0th index. If you say the 0th index is nothing but the uppermost path, uppermost path, and the list of classes here, and there are no files here, basically no images. So we don't need the 0th index anymore. So we have to take the training files from first index, right? So I'm taking training files as from first index, like this. Okay. So if I print the training files, the first thing is nothing but the apple, and the second thing is another type of apple, and the third thing, that is the second index, is nothing but apricot. If you see, it is following the same list here. So it has all the 33 types of folders, file names, everything. So these are in the form of list of tuples, right? And we have to convert them to a proper data frame also in the coming cells. Before that, let's visualize our training data first, right? We know there are some images, and there are 33 different types of fruits, but let's look at our data first. Like, let's print them, or this is an image type data, so let's plot them, right? So I'll be creating a function now quickly and printing them one by one in the same graph in the rows and columns type. Let me copy paste the same code here first, and then I will explain it. So if you see here, have taken class number as 33, because you know there are 33 different types of fruits here, and figure size as 15, 10. So I'm taking a for loop, so I have to plot each and every image in the each class, right? So there are 33 classes here, so I will be taking the first image in each of the classes, and I will be printing them side by side, right, in the same graph. So that's the reason I created this function. So in order to not repeat the things, I created a function taking the training files as an input and class number. What is the class number for that? So the class number here, I'm using it for taking the title from the all classes variable, and also the exact path to that training files, the index number of that class number. I'm using it here. So I'm using this class number to take one by one the image of each class. Then I'm printing this image here using the matplotlib dictionary, and I'm using this subplot here, so it will print in row and columns wise in a single graph, right? So how can you take the subplot here? You can do one thing. The subplot, it has x and y values here. So if you take 33 different types of images, if you want to print 33 different types of images, you can do like this: 5 7s are 35, right? Which is greater than 33. So the size here, this should be like equal or greater than the number of graphs you want to print there, okay? And this I plus 1 is nothing but the position of your graph. It should not be 0. So I'm taking for 0th class, I'm taking the position as 1, and for second one, that is index 1, I'm taking the value position as 2. So like that, it will take from 1 to 33, right? So let's print it. Wow, if you see here, it's printing all the images here along with the title here, right? If you want to verify, you can go to the training folder and you can verify. This is apple, but you can see these are accurately labeled images here. This is corn, this is banana, this is blueberry, blue grape, papaya, plum, watermelon, tomato. So these are the different kinds of images, right? So not only fruits, there are some vegetables here. So we can say, if you want to predict so many images, different kinds of objects, you can add many training files here under these folders, right? You can add a car class inside these images, and add many car images inside that folder, and you can train it. So our next step is to convert this unstructured training files list into a data frame, right? So let's do that. Let me copy paste again, so in order to save the time, and we'll be explaining more accurately again. So if you observe here, I'm taking a training dictionary here first, which is having 3 columns here: the folder path, file name, and the class. First one is the folder path. The folder path is nothing but the file path to that certain file name, right? And the class is nothing but the title for that certain image. Like for this image, it is watermelon, right? So the class will be watermelon, and file name is the file name for this watermelon image, and the folder path is nothing but the path to this watermelon image, right? Like that, I will be storing each and every information in this training dictionary, and at last I will be converting them to the data frame, right? I'll be iterating through these training files one by one, and then I will be appending each of these file paths, file name, and also the class, right? Let's run it. So it is very quick. The folder path, this is the folder path, and the file name and the class, right? You got it right. So this is the training data. We have converted them to the data frame, right? But what about test data? We have the test data also right here. If you observe, test size. So inside this test, we have different types of images. So we don't have labels for those images. So what can we do is we'll be converting all those images inside this folder. Like if you see here, under this test path, we don't have labeled images. We only have 000.jpg, 001.jpg. Like that, we have so many images here. At last we can go, there are 5,000, right? 5,640 images from counting from 0, right? So we'll be converting all this unstructured data to the structured data frame here. So we'll be doing the same thing, folder path, file name, but for the test data we don't have any class, because that is what we are going to predict in this tutorial, right? So let's take, so let me do the same thing here. I have done for training data. I took a folder path, file name, and class. Instead of this class, I will be taking only these two variables, folder path and file name, and I will be creating the test data frame. Let me do this. So if you observe this, I'm taking the test path here, test/test, and I'm taking a dictionary here, the test data, folder path, and file name. I'm not taking the class here. If you observe here again, you can see, and I'm walking through this test path, because I have already walked through this training data and stored the information in these training files, as you have observed before. So I'm directly doing it here, and for each of the file name, I'm taking the folder path and the file name, right? That is very simple. So you can observe this, right? The folder path, file name. Now, if you observe this training data, we only have the folder path, file name, and classes, right? But the machine learning model, what it actually accepts as input is only numbers, right? So how can we convert this file name or the content inside this file name, that is the image, to the numbers? It's very simple. We can use different libraries to do the job for us, right? It will load the image and convert it into a numpy array. Then we can feed that numpy arrays to our model as an input. And also for testing the model also, we'll be converting the image to the arrays, and we'll be sending it as an input to our model, and it will be predicting as which kind of fruit it is. Then our model will be predicting the output. The output will be also in the numeric format, but we have to make some mapping to that these classes to that number, right? Let's do that. So let's convert these images into numeric format now. So I'm taking this fruits df, that is nothing but the fruits data frame, which I have created here, this data frame, and iterating over all the rows one by one, and taking the folder path and file name to load the image. And I'm loading the image. It will be loaded up using this load image function from TensorFlow. Then I'll be converting them to an array using this image to array function from the TensorFlow itself again, and storing the arrays in the images list. And then I'm taking the class for that each row and storing it in the classes list here again. You see? So let's run it. So let's see how our data looks here, the images and classes list. So before doing that, I have to convert them to a actual numpy arrays. So these are the normal arrays now, the images and classes. Now I will be converting them to the numpy arrays, because using numpy library we can do different operations very quickly and easily. So I'm converting them to the numpy arrays first. Then I'm printing the shape for the images and the classes also. Let's see. So if you see here, the complete data images shape, it is having 16,854 cross 100 cross 100 cross 3. So this 100 cross 100 cross 3 is nothing but a single image shape, and these are the number of images we are having, right? The total training data set. And this shape corresponding to the number of images. So the first image for 100 cross 100 cross 3, the first index value, it is storing the corresponding class value, right? Let me show you the first index value for each of the images and classes list here. Images of 0 dot shape. So it is 100 cross 100 cross 3. Even though you print it, it is very huge. So if you see, it is 255 255. It is taking each pixel value and it is converting them to the numeric format from 0 to 255, right? So that's how it is converting them to the numeric format. Now let's see the first value, that is the 0th index from the classes. As expected, it is apple, right? The first folder we see is a kind of apple. So the first one, it is apple. Let's do the same thing for the test images also. We have to convert them to the numpy arrays. Then only we are able to test them after our model got built, right? So let's do that. So as we don't have classes for our test images, I'm only storing the images here in a list, and I will be converting the list to the numpy arrays. So even though we convert them, we do not have any classes, corresponding classes. That's what we are going to print now. So let's print it. So if you see, there are 5,641 test images as we seen here in this test folder, and each image is of 100 cross 100 cross 3 shape, right? So as we converted all the images to the numeric type, but still we do not have the fully training data in numeric format, right? Because the classes variable here, these are still of string, right? So let's think about it, how to convert these strings to the numeric type. Let me print it once again. So if you see here, the classes variable is of containing the string of all the classes for the corresponding image, right? So I will be using two categorical function from quires, also the TensorFlow, to convert these strings to the numeric type. Let me do this. So let me explain you the steps I have done here in this cell one by one. First, I took this classes index, right? So let me run this cell first. So if you observe this class indices, it is pointing out the last index value of that certain image, right? So in these classes, if you observe, it is containing all the classes of our training data, right? So this first value, that is 491, is nothing but the last value of that training data of this type of class, Apple. And if you observe this 1475, it is nothing but the last value of this apricot, right? It is taking the last index. Then if you observe these labels encoded, let's see. So if you observe this cleanly, we have apple as the first one, that is our first category, and for the same apple category it is assigning the number as 491 like that, 491, right? So until all the apples, that is the first category went off, until the first category went off, it will be showing 491 only, and for second category it will be showing the second value that is being assigned in this class indices, and for third apricot it is some 14, right? That number, it will be showing that number. So now what is this label categorical value? Because we have already converted them to the numeric values, right? Then what is use of using these two categorical again? So what it will do is, let me show you first this let me first show you these label categorical values first, then you will be understanding more clearly. So if you observe this, it is creating an array of arrays. The first array, the first index array is having 0 0 0 0 like that, right? So if I took the first one, if you observe from here, it will be all zeros only after printing this. But the thing it is doing here, it is converting that 491 to the array of numeric values. Why? Because it will be easier for our model to get compute zeros and ones quickly than a number, right? So if I take np dot argmax, the maximum value index here, let me show you. Yeah, it is 491. As we seen before, the maximum value, you can say it is 1. So it is assigning 0 to all the values. If you check the list, it will be having 1684. So if you check the list, you will be seeing 16854 values inside this array. Let me show you that. Length of each array. So as I said, you see it is having 16,854 values. So what this label encoder is having is 16,854 rows of arrays, and each array is having a length of 16,854 values, right? Zeros and ones, zeros and so on, ones somewhere and 0 like that, right? And the single array value is nothing but it will be having like this. And such type of arrays we have 16,854 arrays, because for each corresponding image it is creating an array of values with the maximum index value at certain point where it is pointed to one class index here, right? It is clear, right? Now everything is converted to numeric format, the images and the classes. Now what is the next step? So the next step is to split our data into training and validation datasets, right? Let me show you that. So I'll be using this train test split from sklearn to do this job. I'm taking the images first and label category as by value. Images are x values and label categorical all values are the values which we are going to print, right? The area of the values here. And test size is nothing but the validation size. We are taking it as 20%. Let's run it. So it's completed, guys. It took some time to complete this split, train test split. So in the next step, let's see the shape for this training and validation datasets. So if you see, there are 13,483 for training dataset and 3,371 for the validation datasets, right? Now what I'm doing is I'll be converting these training datasets images, the image arrays basically, to the tensor slices. So let me do this. So I'm using this from tensor slices function from TensorFlow to convert these training images and labels to the tensor slices, right? So it will map these training images and also the labels, and it will create a tensor slice out of it. This will be, so these are numpy arrays at the beginning, and at the end it will be the tensor slices. Let me show you that also. So if you see the check types, TensorFlow Python data type from TensorFlow slices. So this is the data type here. So if you want to see this training data how it looks, you can do it using this iter. So what you can do is iter of this training data set, and what you have to do is next. So it will give the first value, and then whenever you use this next again, it will give the second value like that, and so on. It will give the next values. So let me do this. So if you observe this, it is the array, as usual array that we given it as an input, and at last, if you see, this is the output label, right? It combined both of them and it created a tensor, right? So that's how it works. So it will give the next value, combine together the input value and also the label. Like it will return a tuple, right? See, it is a tuple of two values. You see the comma here, it is a tuple, and the first value in the tuple is nothing but the input image value, and second value is nothing but the label value. You can access it using the 0 and 1, and then you can convert them to numpy arrays by using .numpy, and you can do whatever operations you want, right? So the next thing I will be doing here is I will be preparing our training data set using a function, because for training this data we need some pre-process be done before we feeding this data to our model, right? So let me copy paste that function here first. So this is the function I'm talking about, prepare. So what this function basically doing is taking the data set and also some variables here, shuffle, augment and test. So shuffle, what it will do is it just shuffle the data randomly, right? And then test will send it as true whenever we are sending the test data to make the preparation, right? What it will do is it will rescale our data, that is nothing but it will rescale our data to 0 to 1 range instead of 0 to 255, right? The test data basically. And after, if it is not test data, then we will recycle it using the xy values, basically the training images and also the labels, right? If it is only test, then we only use the x values, that is only the images, because we don't have the labels for test dataset, right? And for shuffle, as I said, it will shuffle the dataset. And then augment, what it will do is, if you see the data augmentation, it will flip the image in the horizontal mode randomly, right? The training data basically. Then it will send the buffer stored in the memory, basically the dataset, back to the variables, right? Let me run this. So now let me call this function to prepare our training, validation and test datasets, right? So for training dataset, I'm using training dataset and shuffle as true and augment as true. For validation dataset, I'll be sending the validation dataset, but shuffle is false and augment is false, and it is not test data, it is just a validation data. For test dataset, I'll be sending the test dataset and test as true. Of course, it will not shuffle because it is not training dataset, right? Let's run it. So it is done. If you want to see this dataset in the training, we have to do the same thing. Iter of train underscore ds, and let me convert it into a list. Let me access the first one. So if you observe it here, it is 4-dimensional now, of batch size 128. I have given it earlier, right, here before this function. And each batch size, it is having 128 rows, and in each batch it is having 128 rows, and each row it is having the same image, 100 cross 100 cross 3, right? And if you observe it here, this is the training images dataset, and these are the 128 labels. Those are the classes we are going to predict, right? So our next step is to train our model. Before that, we have to define our model, how it the structure, basically the number of layers, the activation layer and the hidden layers and the output layer, basically what are the optimizers we will be using, and also the loss, everything we have to give, and we have to create our model, right? Let me do this. So you see this model is the conventional layer I'm using. So the conventional layer is the first layer I'm using here, and the input shape, you know, it is 100 cross 100 cross 3, and activation function I'm using it as relu, and kernel size as 3 and filter as 5. And next layer is nothing but the max pool layer. I'm using pool size as 2 and padding as valid. And next layer as flatten, so it will flatten all the arrays. Then the dense layer at last, and the length is nothing but a number of neurons. Here it should be the length of classes, because it will give the probability. So the highest probability one will took it as the output value. Activation softmax. So the compilation, I'm using loss as categorical cross entropy, and optimizers, there are a lot of optimizers. So in this case, I'm using Adam optimizer and matrix as accuracy, right? After that, at last, I'll be using model underscore 1 dot summary to see the overall summary of this model, right? Print it. I'll be doing one more video about this convolutional neural network, so you can be very much clear about these filters, kernel size, activation layers, and hidden layers, and also these max pool layers, everything about them in a separate video. Until then, subscribe. And so if you see here, the summary, first one is the conventional 2D layer and max pool layer, and then flatten and dense layer at last, right? So let's fit our model first. So I'm fitting our model with the training data. I'm just using 2 epochs here. So you can use number of epochs, many number of epochs. But for now, I'm using 2 epochs. If you don't get more accuracy, you can use more epochs. Okay guys, the training is done now. It took around 1 hour for me to get the training done completely. So the next step is to save the model, because we have trained this model by putting this much time into it. So without losing this model, let's save it. I have saved our model using .quires format here. If you see here, the model is saved here. model1.quires. Now we can test this model using test data, right? So let's do this. Model underscore 1 dot predict of test dataset, right? Let me save it in y predict, like that. Oops. Model. So let's print this. Let's print the length also. So it is having 5641 test images, right? So let's consider the first one, first index. Let's print the maximum index value in the first predicted one. It is 1475. So let's take the classes. If you observe the classes we have done like this, or else you can take the classes indices here, copy the classes indices, paste it over here. You see 1475, let's say 1475 is for apricot, right? So let's try to visualize this output, then we look for a validation, right? So how can we do that? We can do that using iter of test underscore ds, like that. And home, we have to take the next value, that is, it will take the next value of first value, second value, third value, like that. It will take in order. We can say it as list, like that. So it will convert everything into a list. Test ds list, like that. Let's save it. Oops, I have to give one more. Okay, now let's take test ds list of zeroth value. Let's see. It is a tensor of 128 data batch size, right? So let's take the first value in it. This is the first value, right? Let's try to plot this value. Plot dot I am show. So it is, see, it is apricot, right? So if you want to test it and see the image and validate everything, you can do this. You can plot the image using this. You can see for the first value again, first index value, and then you can see here, you can take one here again. I think it is grape, right? So let's see. 6644, it is grape blue, right? You can see. You can go for some other index 2 and taking it here as 2. 8582. I think it's mango, right? 8582. 8582 mango. So if you see here, it is predicting our test images correctly, accurately. You can take this model and put it inside your web app, and you can just upload any image on the trained dataset. Well, we have to train the images first, right? Not all the images, but you can take few images and train them, and you can use it in the web app, and you just have to upload the test image, and you can print it in the page like it's saying printed like this. I'll be showing that web app in the next video. Please subscribe to not to miss out any of the upcoming project videos. Thanks for watching.